someone is just joining, my name is Cristián. I work here in Berlin. And yeah, I do Python and C++ stuff. So this talk is purely about the situation that you will have at some point the need of exposing your existent C++ example or project to Python. So of course, we can do it like we were previously discussing, this kind of embedding the interpreter inside and maybe having some tricks. But this is a more clean way in the sense of like how we can bring this huge project into Python and just use it from Python from once. So as we always see, I mean, there's, a couple of similarities about Python and C++ in general, general purpose, multi-paradigm. Then you have some difference like the statically typed. Then you have, different, it's not compiled, it's interpreted. They have the memory manipulation, and also about code reliability kind of like depends of how good you are with the others, right? So the idea, I didn't change this. This was a talk from the different conference that I went. So in Python, it's kind of simple, the hello world there. And then in C++, it's of course really simple. So why is people scared about C++ in general and when they are using Python, right? I think my theory, I don't want to start any holy war here, but my theory is because of this. Because when you start to do meta-programming and you want to do some weird if compiles time, so it's kind of scary. Still, you can get through it, but at least for me, it's still scary. So there have been a few changes in C++ 11 that kind of are making our life easier, well, the people to opt to use them. Because again, that people always never auto, this kind of thing. But in any case, it's kind of make your life easy in the sense of like, inferring the types, the auto, you have also the decal type. And then also the evolution of the for loops is kind of like really, at least in my opinion again, it's kind of convenient that then you are getting, ranges, and if you expose it again with auto, you kind of like get more like a generic for loop, right? But if you go a little bit further, also lambdas are kind of like really in the sense of like, it's kind of like easy to understand and do some stuff that maybe you already know. But here in C++ 20, at least, I see some patterns that, I don't know, again, for me, it looks kind of familiar. I mean, when you have this code there, I think that if any Python developer kind of sees it, it will say, okay, that's that, right? I mean, it's exactly the same. What I know, I mean, maybe, of course, there are some semicolons extra in the first, but after all, I think that the idea is quite nice and how we can kind of like extend the for loops that we have in C++ to Python. The same thing for the simple example. In Python, you will kind of do how to detect a palindrome like this. I commented the Pythonic way of doing it, but this you can also have it like this, which is also kind of resembles what you can do in C++ 20, like this. It's kind of, I don't know. I don't know about you, but I mean, for me, kind of like they look more similar to each other. So at some point, I think that there was a talk, I forgot the exact name, but the idea of the title was something like, if you really push C++ harder enough, it kind of becomes Python at some point. I don't remember who he gave, I think it was CPPCon 2017 or 18, I don't remember. So the idea is that not everything is lost, and of course, there is some connections, and nowadays you see most of the most popular Python models for doing data and stuff are based in C, in C++, or in Fortran. And mainly, one of the latest that we were discussing in the previous session is based in C++. And people love it because it's so efficient and everything, so it's like, C++ is there, right? So that's why I want to present today Python's plus, no, this is a joke, but the idea now will be that the same way that these people did it in PyTorch, to just exposing Torch to Python, that maybe we can try to do the same with the projects that every one of you have already, and you can still kind of improve the Python ecosystem. Because what are the usual thing that we heard? Python is slow, well, I think that's mainly that one, or I don't like white spaces, and this kind of things. So you can make it better. I mean, I know that it's harsh to hear, but I mean, if you don't like it, maybe you can contribute and make it better, and at some point we can jump into it. So what is Python? Python itself is a declaration, I mean, it's a language, but has different implementations. I didn't have the time to set up here, but if you want to use Python, you can use Jython, for example, which is a Java implementation of Python, and it is still the same interpreter, the same thing, but it's written under the hood in Java. You have Rust Python, which is a kind of a new project. There is some people went crazy and said, you know what, let's rewrite everything in Rust because Rust is amazing. And then he rewrote everything. You have other type of Python, like you have a stackless Python, Iron Python, if you are more into the Windows C# things. But the de facto or the standard Python that we all know and we execute is written in C. And this is C Python. The idea of C Python is that the model is based in this little structure that is called PyObject. And everything you see around, everything is around PyObject. So they encapsulate here the information of any type in Python. So this kind of looks like 3 lines, but I guess that you already got some idea that here is where all the magic happens, because that's a really long struct with all the different cases, with all the conditions to see if this implements some numerical iterators, if this has some different encoding. Everything is there. So that's the large structure there. But that's the idea. So Python is written in C. So now, with this knowledge, the most important thing is that now you can understand that joke. Because it's really a bad joke, I know. I should remove it. So how we create a Python module? So let's see how we can create some Python model. So let's go back. It's not where we want now. I know that you can read, but just let me go to the code. What's Summit? I think that I have an environment here. Yes. Okay. Okay. So I guess that you will be able to read here. So we will base our code in really a complex scenario, which is nothing else like a hello world function. So in this case, you have there a really simple function that just prints hello world. So in this case, you can see here that everything that we have inside this file, I will just go quickly down. Whoop. That's the only thing that is required to create a new Python module that contains only one function inside that is called hello. So that's it. So as you can see, you declare the function, then you have some documentation of the function itself. You see which type of functions will this module include. And then again, in the module itself, you need to pass, these are the functions of this module, so you can pass it again to this struct. And as you can see, everything is like PyObject or Py something. Then you do some initialization of the module, and you create the Python module. So this allow you, the make process is, I wrote make files just to highlight how to do it. So you mainly do Python setup install one of the users, and then you have the thing build. And this, of course, generate some specific shell libraries there that includes, this is what you have in your model. This is what Python is able to import. So then you have your Python code that I just executed, and it's just that. We just created a method called, a model called simple, and then we print the function called hello. It's kind of simple, right? But the problem is that as you saw inside this code, even though it was a couple of lines, there were many things that you need to know by heart, right? Why do you need to pass the functions in this way? How do you declare? What is this head anything? So it's kind of complicated. So that's why for this specific case, this is kind of simple. But what happened when then you have like software like it's a little bit larger, like Qt. So it was impossible for us, try to write everything from scratch, right? So now, let's go back to the presentation. So the idea is what about Python with all this kind of thing, right? So just want to highlight, when the project started roughly around 2007, at the moment, the idea was using raw C Python, as you saw, and manually write, or maybe generating some script that add the functions there, and generate beautiful Python that way. The other option was Swig and Boost Python, right? So let's look at them. So in Swig, again, same example. I'm not lying to you. This is our complicated function that we want to expose in this new module called simple. And the Swig process, it's kind of really simple. So you do, of course, I forgot the interface files. This is the file that Swig needs. So it's like you declare the name of the module and then the function that goes inside. That's it, nothing else. And then you can, again, execute code like this from a file like this. But what is the problem with Swig? This is the wrapper that is being generated by Swig. We are in 4% of the file. So yeah, we can speed up the things. We are 15. So I guess that you kind of get the feeling, right? I mean, if you're shipping something like this, so at the end we have 3,490 lines. So I know they need to infer stuff, they need to cover all the cases, they need to take care of all the situations, but still, it's really a burden. So then there was Boost Python. So okay, so Swig is not efficient enough. Where we Boost. Same idea, the file, I'm not lying. This is the way that, you need to write it. So this is Boost, it's more like friendly with C++. You can just declare this thing here and use this macro, and then you have the name of the module and then the function that you want to add. Same story, you compile it, you have your main.py, same idea, and then you can do it. In this case, the code is, I don't have it generated, but the size of the shared object is roughly the same as the other one. So you are still need to carry this burden with you. So at some point, well, I imagine this is story because I never met the original author of Python, but that they thought like, well, this really sucks. So I mean, we need to look for something else to kind of do, right? So as I said, I mean, they kind of like the development of Qt 4 was in 2008. 15, they started porting Qt 5. 2016, it was back to the Qt project, and then we released it last year. So what is the magic about? I mean, if we didn't use Swig or we didn't use Boost Python. So this is the process of how Qt for Python is being generated currently. We have a tool which is called Shiboken. We will not talk much about Shiboken because after this talk there is a specific talk for Shiboken, so you should stay seated here. So we use Clang, of course, to infer all the information from the classes, methods, attributes, blah, blah, blah. And we extract this information. We have something that is a type system, which is nothing else than an XML file where we can kind of deal with the cases that we don't know how to deal. Like, for example, what is a void star in Python? We don't know, right? There's a reference argument. In Python, everything is copied, everything is value, so you cannot change reference of stuff. So you need to modify the API. And this is a thing that has been done. I mean, you have many functions that they don't work exactly the same as Qt because you need to adapt it to what Python can offer, right? And the same idea is that one important issue here is about ownership of objects. Since we are using C++, of course, under the hood, I mean, we are calling the Qt API. Who owns the object? Because we have the Python objects. Is it C++? Is it Python? When we release, when we delete stuff. So all these kind of situations, we need to kind of do it by hand in the type system, which is at least less pain of writing everything with CPython. So after this, Shiboken outputs some CPython compatible code, which is nothing else than some code that you can compile and generate this shell library that can be imported from Python. So it looks really simple. Of course, there is some stuff inside, but yeah. So Shiboken, as I said, that's the website of the documentation. At the moment, I know that it needs more love, but it's a starting point. As I said, I will not speak much about Shiboken, since the next talk is purely about a real case of using Shiboken for something else. So on the same idea, we have other nice options. And since there were some comments here about PyByte 11, maybe we can check it out now. And there's a couple of other there. So let's go for PyByte 11 now. So again, same story. Let me show it maybe. We have a function, then a string, you use PyByte 11, and then you declare kind of similar to what we saw in the boost case. And you have the same scenario that you can say, okay, there will be a function that will use the function that we define, and then you have some information there. So it's really easy and straightforward to use, but it's kind of a new tool that kind of was around. So again, I mean, after this, you have some shared library there, and you're able to run this kind of code the same way that we did with the other ones. So this is really kind of cool interface. Then you have other things like CFFI. That is a different approach. So in CFFI, you have main. Yeah. So here, the thing that you are kind of doing is you have some library. You are loading directly the library and printing the result of this. So this, I have it here in simple build it thing. Yes. So this is the CFFI code. So in this case, we are declaring the C++ component, or in this case, the C component, inside as a string. So this approach, maybe for naively as it sounds, it's kind of still used. And for example, if you're familiar with CUDA, the C extensions for programming GPUs, PyCUDA is kind of does this kind of a similar way, declaring the kernels that you need to execute on the GPU, again, as a string in Python, so you kind of compile it, and then you kind of able to execute it. So this is C, and I didn't know there's an equivalent for C++. So you can also do kind of nice things like this. And you can still generate some Python model based on some C code, C++ code, I mean. So this one is a really nice tool I discovered recently, and they use Cling underneath to kind of like compile C++ code and interpret and expose the objects to Python. So it's kind of a really nice approach that maybe we can take a look of it. And there are other kind of approaches that, I mean, we show there, yeah, there was zip, and also have here C types. C types is also kind of a different approach. You have your file there as a C, but you are kind of like more in a hacking way, like loading directly the shared library object, and then you need to have some weird, REST type thingy and getting the sharp pointer from the. So it's kind of more tricky, but it's also in a way of interacting with C. And then we have zip. Zip is, if you don't know, I mean, besides PySet, there is also PyQt, which is another set of bindings for Qt that they have developed by a different company, and they also have their Shiboken that is called zip. That also you can do some stuff with zip. So I also have here an example. This is more complicated. You have the function there, and as far as I know, you need to define something that's called zip file. Yeah. So it's kind of similar when we also saw in the past with Swig. So it's kind of a similar approach. And then after you compile, I think I was not able to compile this thing. Maybe it will not work. It worked. But it's again same idea. So again, I mean, you don't need to remember everything that I just told you about all these modules, because everything will be available in GitHub or something, so you will be able to play around with the same things. So the use case that I wanted to highlight, and this going back to how as a C++ programmer can improve the Python ecosystem, is that there is a specific case. In Python, there is a function called glob. Maybe you heard of it. So if I do Python, import glob, I think that is glob. No, I don't even remember. Let me look here in the benchmark. Glob. Glob list. Whoop. Yeah. So it's nothing else than kind of like listing the directory, but then you have some nice options to list what you currently have, or even doing recursively, so you can go inside, and list all the files that you have inside some project, for example. So this is a way of doing the two things, like recursive or not. It's kind of straightforward with some Boolean. Lately, there is an amazing model in Python called pathlib that kind of like put object-oriented paths, so you can access to parents and children and these kind of things, and it's really, really cool to use compared to glob. It's kind of the same idea. I also have kind of a glob implementation there. It's a little bit faster. So I wanted to show here, for example, some benchmark. Maybe it will take. So yeah, I created you can see there the top, there is this data directory that has 1,000 directories, that inside each directory there is 1,000 files, empty files, but still. And the thing that I am running here, I will show you two benchmark, or maybe one is okay, is just comparing glob, as I told you, the padlib, which is the new thing, and something that I call fast glob. So as you can see here, non-recursive 0.002, recursive 12 seconds, 76, 8 seconds. And this is 0.05 and not even 1 second. So on the same, that's if you didn't believe me, maybe I was doing some bash stuff and I was tweaking the numbers. I also have one that pure runs in Python with the timing module from Python itself. And it's kind of the same story. I mean, I can already spoil you that the difference is really, really, really amazing. So what is this fast lift that I was mentioning to you? As you can see there, look at the comparison. I mean, we are getting a lot of speed, right? So what is this sophisticated model that I'm talking about? You're familiar with C++, of course. You know the standard file system. And then the only thing that I am doing here is just to do the recursive directory iterator. Nothing else. I mean, everything else that you see around is kind of like why Python encourages you to how to build some modules, like this thing to parse if there was the recursive, for example, variable, if it's a true or false, so if I do recursive or not. So as you can see here, I'm just getting this. This is just for the argument that we have. And then I am creating a Python list from the CPython backend as you learned before. And then the only thing that I am doing this is using recursive directory iterator or directory iterator. Nothing else. The rest is exactly the same CPython code that I showed you with the hello world. I just modified this function. And still you can get a lot of speed up in the things that you have. So there is really a motivation that at some point, if you're like doing some Python application, and this is so slow, maybe you can even like implement yourself. I mean, you know C++, you know how easy it is to do these kind of things. So you can play around, expose your own models. Maybe you could, at some point, contribute it to, I don't know, to the Python ecosystem or something. So as a summary, of course, there are some limitations on different things and different licenses, different compatibility with Python and everything. So you can find this nice table here. I mean, most of the stuff is C++ compatible and the licenses is as you wish and as you prefer there. Shiboken here is highlighted. You know, it's LGPL version 3. And this is still compatible with Python 2, but we are planning to destroy this in maybe next year by Qt 6 or something. So yeah, I don't know if you have any questions about the talk, but now I think I still have like maybe 5 minutes. Yeah, I think I have 5 minutes if you have any question. No questions? You're not convinced? Okay, two. Okay, first.
Briefly, what does Shiboken do better? Make smaller binaries in C.
You will maybe find out in the next talk. Well, I think that it's the most convenient part is how to handling all these special cases that I was highlighting before. In the other scenarios, even in Pivot 11, I found it a little bit trickier, maybe because I was used to the XML approach, but for me, it kind of makes sense to have an XML that I can just edit and add some files, and we have many nice features there to remove arguments, to convert automatically the type of the thing. So in my opinion, that will be the most beneficial part, like the easiness of modifying some stuff. And there was another question there? It was the same size of the shared library, was the same size of the Swig one. So there was a lot of code generated, and this is one of the problems with the team. When they started PySide, they saw the size of the things. It was like, oh, we cannot ship this is too large. Yes. Yeah, no, I mean, yeah, but I mean, the ones we compare, I don't have the numbers, maybe I should have measured, but the shared libraries are way smaller than the one that's generated by Boost. Do you have any other question?
How good Python covers the Qt API in general, Qt modules, multimedia, for example?
What do you mean? I mean, we are, it's exposing the same C++ code, so everything that we have in Qt multimedia is just, you know, being executed from Python.
So there are no restrictions, in fact.
As far as I know, no. Maybe there is an open back on some specific.
We're talking about P-side mostly, yeah.
Yes, PySide, yes, it's true.
And P-side 2 is in mainline Qt from 5.12, yeah.
PySide 2 is starting from Qt 5, and the release officially was for 5.12. Yes. Any other question? No? Okay. Thank you very much for joining.